Happy Earth Day, fellow explorers. This is Tony with Fountain Systems Network, and we are here in pursuit of low-carbon innovations for industrial wastewater treatment. This is our Earth Day episode, and I'm going to cover a subject that's near and dear to my heart: evaporation and evaporative distillation. These are really important to me because they're intimately tied with nature's hydrologic processes. In this episode, we're going to look briefly at how evaporation works in lithium mining and other manufacturing operations. We'll look at evaporative distillation and solar stills. And then finally, we'll look at evaporation and how it ties into industrial wastewater treatment. Stay tuned, and I'm going to share with you some of the compelling aspects of evaporation that led me to start this whole Fountain Systems pursuit to begin with. So this pursuit on Fountain Systems Network first started in 2014 with an idea that I had for a solar still, which I would go on to get patented in the United States. Solar still is a kind of water purifier, and it utilizes evaporative distillation to power the water purification process. Now, if you haven't already seen it, I want to post a link here to our entry for the 2020 Solar Desalination Prize, which introduced the Fountain module and the Fountain Systems array, both of which utilize this process of evaporative distillation. Now, evaporative distillation is nature's process for separating dissolved solids and contaminants from water. And I'm going to show you here next a very familiar example from nature demonstrating this phenomenon. Imagine, if you will, that you are standing on an overlook with the ocean extending out to the horizon. The sun has been warming the ocean all season, and over that time the ocean has become very warm. As you stand there and watch, huge quantities of water vapor are being evaporated from the surface of the ocean into the air. This water vapor freely circulates in the atmosphere as highly pure water in the form of gaseous vapor, and it leaves all that salt behind in the briny ocean. This is evaporative distillation, and it's nature's eternal process for separating water from contaminants. Evaporative distillation is constantly happening all over planet Earth, from our bodies and from every puddle and river and sea, forcing gigatons of pure water vapor into the atmosphere every day. And much of this water vapor gathers and condenses in the atmosphere overhead to form clouds, which in turn become rain, which returns to land and sea again. It's a pretty spectacular thing to appreciate, don't you think? If you're an explorer like me and you want to dig a little deeper into this phenomenon, I've posted a link in the description below, and it describes evaporation far better than I ever could. Solar stills capture this phenomenon of evaporative distillation within a device, and many people have worked to develop them over the decades. The last time I did a patent search in 2014, I discovered that the Patent Office has a dedicated category just for solar stills. Back then, there were more than 600 patents going back as far as the 1870s in this category. These are just a few examples of the strange and wonderful world of people trying to come up with innovative ways to separate water from contaminants using just the power of sunshine. Very few of these devices make it to market, and of the handful that are out there today, they appear to be sold in very low volume and in niche markets. But at the same time, solar stills continue to be a very popular and perennial technology for exploration, as suggested by this video clip produced by engineering students in India just recently. So now let's look at some examples using evaporation for industrial processes. First, we are going to look at evaporation in manufacturing applications, and then we're going to turn and look at evaporation for industrial wastewater treatment. Evaporation is used in manufacturing operations to separate water from the dissolved solids that people are trying to get at. So let's look at this example from southern India, which is a salt works. Seawater is introduced into these evaporation pans, and the sunshine drives the water away, leaving the salt behind for people to harvest. I think if we could go back in time, we would see this kind of operation in use around the world over many thousands of years. But back to the present day. Here are some evaporation ponds used for potash or potassium mining in Moab, Utah. In this case, water from the Colorado River is first pumped into underground mines to dissolve the potassium there, and then they pump that water in turn up to the surface to these evaporation pans to evaporate the water out of the solution, leaving the desired minerals behind. And here, now these are very famous and controversial, these are the lithium mines in the Atacama Desert in Chile. In this case, the groundwater already has the lithium dissolved in it, so they pump the groundwater up to these evaporation pans and they let nature do its work, separating the water from the dissolved minerals. This is just the first step in the separation process here, and after evaporation, the solidified minerals go through a manufacturing process to extract the desired lithium. Now, I'm sure some people see an environmental catastrophe here, and with current rates of extraction and methods, it probably is a catastrophe in the making. But at the same time, if we can move forward with a serious commitment to the biological and hydrological capacity of this special place, I see the potential for Atacama lithium to be the lowest carbon lithium on the planet. Much as people will pay a premium for organic produce, I think people will pay a premium for sustainable lithium from the Atacama for their electric car batteries. So finally, we'll look at evaporation for industrial wastewater treatment. The predominant application that I've found so far is in tailings ponds or evaporation ponds. Tailings ponds are used to impound and concentrate industrial process water at the end of its industrial use, like this one for coal ash or for phosphogypsum, for example, which my fellow Fount Systems explorers are already familiar with. But evaporation ponds can also be relatively small and benign, like this one that is used to concentrate brine from reverse osmosis water treatment for a small rural community in California. Just to be clear, evaporation ponds are not a water purification or a water treatment strategy. They're just ways to manage the volumes of wastewater that get stored on site, and it happens through evaporation. So they clearly can become outright environmental hazards, like this phosphogypsum stack in Piney Point, just south of Tampa. I'm sure you all remember our episode from 2 weeks ago that described the failure of the holding ponds there and the state of emergency that was declared. These holding ponds are not a sustainable long-term solution. The contaminants just build up and build up over time, and unless a use is found for them or manufacturers are compelled to deal with their waste properly, they'll just continue to build up, unfortunately leaving the problem for future generations. Well, it was a little bit longer episode today. I hope you found it rewarding and worth your while. I'd like your thoughts. Do you think that evaporation or evaporative distillation can play a role in our low-carbon future? Please leave your comments below. If you like what you see here on the Fount Systems Network, please like and subscribe to the channel. Follow us on Twitter @FountSystems. And thank you for watching, everyone. Remember, keep exploring, keep growing. I'll see you next time.